Hey guys, we're going to do the video midterm practice test 1. So you can take this test as many times as you want. If you notice on here, you'll find this under quizzes or assignments. I think I set it at 8 times you could take it. And this is a homework grade, and the computer will take your highest score. Okay, so I copied these questions over so I could kind of write on them here. Let's do it. Sorry about that. It says, which theorem is illustrated below? So it looks like this is a proof. Interesting, right? It says angle 1 and angle 2 are equal to 180. That's because of the linear pair postulate. Angle 2 and angle 3 are equal to 180 because they're a linear pair. Now it looks like they set this first set of stuff is equal to 180, and the second set of stuff is equal to 180. So they set this first set of stuff and the third set of stuff equal to, that's called transitive property. It's kind of like substitution, but it's with 3 things. Substitution with 3 things. Then it looks like they subtracted the measure of angle 2 on both sides. So they just kind of subtracted, so that'd be subtraction property of equality. And this is just the definition of congruence. So if the measures are equal, then by the definition of congruence, you know that the 2 angles must be congruent. So essentially, they've come to this conclusion that these 2 angles are congruent. What they've done is they've proven the vertical angle theorem. Angle 1 and angle 3 are vertical angles, but that's what's called a proof, to prove one of those theorems. Okay. Question number, going the wrong way. Question number 2. Okay, so I copied these out of a different book. So sometimes it'll have a different number, but obviously in the computer it's 2. How can you construct a line through P that's parallel to L? So we're looking for, how can I draw a line there without guessing, with a compass and a straight edge, right? And it doesn't even have to be a ruler, just something straight to trace against. So if we think about this, I've only taught you how to cut a line in half, how to cut an angle in half, how to copy an angle, and how to copy a line. But also, when you cut a line in half, or it's actually a line segment, when you actually cut a line segment in half, we draw an arc from A and an arc from B, and we identify those intersections. And when we connect those lines, notice it does cut this in half, but it cuts it at a perpendicular. So an interesting way, we can use the same technique to draw a perpendicular. And so what is a parallel line? Well, actually, a parallel line would be a line that's perpendicular, and then a line that's perpendicular again. Notice the red line, maybe I'll use 3 colors here. The red line is perpendicular to the blue line, and then the red line is perpendicular to the black line, so that's going to force the black and the blue line to be parallel. So this should help us arrive at this concept here. I would construct a line in through P that's perpendicular to AC. So that would look like this. I'd construct a line that's perpendicular through P, that perpendicular to AC. And then I'm going to construct a line that's perpendicular here. And voila, I'm going to have a line that is 2 lines that are parallel, which is what I want, at P. It's pretty cool. Using just the tools that we've learned. This isn't a new construction, it's just using some of the other constructions on top of each other. Okay, so question number 3. What is X? So isosceles triangle means two equal sides, two equal angles. See, those two S's kind of remind us of that. So let's set those angles equal to us if we can't. Oh, okay, so these two angles are equal, which means this is where I could fold it. And this side has to be the same length as that side. Now this side is 10, which won't really help me unless I'm trying to find the perimeter. Okay, so let's get X by itself on one side. Right? And we get X is equal to 4, and that's one of our choices there, right? Nice work. Question number 4. In the figure shown, angle 2 is 65. Okay, so we said in class, if I have a line and those angles are anything but 90 degrees, then all the acute are congruent and all the obtuse are congruent if they tell us these lines are parallel. So see this little caret on there? They do. Also, any acute plus any obtuse adds together to make 180. So that means if this is 65, then this is 65, this is 65, this is 65. All those are 65. And these are all obtuse, and they have to add. So if the acute one is 65, we can solve for the obtuse angle. The obtuse angle has to be equal to, what is that, 115. Okay, so that looks like it lines up with my choices, doesn't it? Now, let's see what they're asking. They're saying angle 6, so that is the acute one. Angle 8 is obtuse, that's going to be 115. So 6 is 65, right? And 8 is 115. Beautiful. So we have our answer. Let's check out number 5. So number 5 states, in the triangle shown, if A is 38, so I'm going to make that 38. Notice that's 90. And using the angle sum theorem, triangle sum theorem, I know that angle B has to be, I can solve for angle B. A is 38. B I can solve for. C I know is 90. So angle B, I can combine these, right? Angle B is 52. Now, what are these other marks, tick marks, right? These two sides are equal. These two sides are equal. And these angles are equal. So this is essentially saying if the hypotenuses are equal and the legs are equal, remember we call them legs if it's a right triangle, then the hypotenuse leg theorem, and it is a right triangle theorem, states that the corresponding angles would be congruent. So if we keep track here, if I go from the hypotenuse to the angle to the leg, or the hypotenuse to the angle to the leg, then that means this would be a corresponding angle. Angle A has to be congruent to angle D because they are corresponding parts of congruent triangles. That's the theorem CPCTC. Now they didn't ask for D, they asked for E, but that must mean that B, we also know B corresponds with E because of CPCTC. That is also a corresponding part. So E is 52, there's my answer. Nice work. All right, question number 6. This is similar to the ones we did in class. So an octagon, which looks like a stop sign, right? Has how many types of symmetry? So reflectional, meaning I can flip it over. So I can fold it, I think 16 different places. So that's an absolute yes. Point symmetry means it only has its smallest angle of rotation is 180. meaning it won't look like Z. It doesn't look the same sideways. So if I turn my head, it looks like the letter N. But Z does look the same right side up and upside down. So I'm going to have to say no for point symmetry because it definitely has multiple angles. So as it looks here, if you switch it 90 degrees, it will map on itself as well. So it definitely doesn't have point symmetry. So I'm going to say B, yes, reflection, no point symmetry. All right, question number 7. What's the least angle of rotation for a heptagon? So we talked in class, that's a 7-sided shape. So the formula for the smallest angle is 360 divided by the number of sides. So 360 divided by n, if n is 7, gives me 51 and a decimal. But they told me to round to the nearest whole degree, so I'm going to pick B. Nice work. Okay, here's our octagon again. How many lines of symmetry? So as we said, I could be folding it at the midpoint of the side. So that would be 1, 2, 3, 4, 5, 6, 7, 8. Wait. Uh-oh. I think I'm going to have to fix this one because I'm counting this 4 and 8 twice. Oops. I think I maybe went over in class. Yeah, so 1, 2, 3, 4. And then I might have to fix this question. I could fold it on its point. So 1, 2, 3, 4. Okay, so that's a total of 8. And that is one of my choices. But I think I marked that one wrong. So yeah, I got to go back and fix that. Okay, 8 is definitely my answer there. Yeah, I was rushed in class. Question number 9, in the figure, what is X? Okay, so I have a side that matches, a second side that matches, and an angle that matches. And the angle that I know about is trapped between the two sides. So the side angle side triangle congruence theorem states that this triangle, ABC, should be congruent to DEF, which means its corresponding parts should be congruent. Corresponding parts of these congruent. So since B and C is first and middle, E and F should also be congruent because they're a corresponding part. So I can set them equal. 9x minus 17 is equal to 4x plus 3. So if I subtract 4x, I get 5x. And if I add 17, I get 5x is equal to 20, which leaves me x is equal to 4. All right, let's look at question number 10. Here in the triangle, what would angle A be? So we see that there's 3 angles, and we know the triangle sum theorem states they should all add up to 180. So if A is 3x plus 20, B is x, and C is x plus 15, then I can combine them. And this is just substituting in these values they've given us. So to combine these terms that are alike, 3, 4, 5x total, and combine these that are alike, 35, I can subtract and then divide. So what do I get? 29. Well, hold on. It asked for angle A, not X. So that one's there to kind of distract me. What would angle A be? So now I can substitute that back in. 3 times 29 plus 20. So that's 7 to 87 plus 20 is 107. There's my answer. Now, if you're still not sure, you can plug 29 back in here and back in here and double check that they do add up to 180, just to be sure. Wonderful. Okay. Where are we at? 2 more questions, 11 and 12. So it says CF is 5, okay? CD is 12. Okay. EF is 5. So notice something here. I have two sides that are equal and a straight line that's 90. This would also be 90 because that's a linear pair. And that would have to be 90 degrees. It can't be anything else. And so now I notice that they share this line. So that's called reflexive. Notice that FD is congruent to FD. They share that line. So this evidence spells side, angle, side. We know that the triangle on the left, CFD, is congruent to the triangle on the right, EFD. So since the first and last side is CD, and ED is the first and last side, then those are corresponding parts of congruent triangles. That way we can say that that has to be 12, not just by guessing, but I know for sure. Now, I have the information needed to find the perimeter, which is all the way around. So let's just count that up. I have 5 and another 5, which would be 10, right? And another 12 and 12. So that'd be 10 plus 24 makes 34. That's one of my answers, D. Nice. Okay, last one. In the figure shown, what is the value of X? So once again, I have a side that matches and a second side that matches and an angle that matches. So given the side angle side theorem, this triangle ABC is congruent to triangle DEF. Therefore, BC is first and middle is congruent to EF, first and middle. I can set these equal to one another, and that's the corresponding parts of congruent triangle theorem. Nice. So if I subtract 3 on both sides, I feel like I'm getting X is 4, and that's what they wanted. X is 4. Popular answer today, 4. Thanks for joining me, guys.